So today we'll do the hands-on. So why don't I open up the browser and push this slide a little aside. Okay. So I need to go to USR local and find out MySQL 9.0.1 and then bin directory where we have a MySQL file. This file is the command that we are going to run. So MySQL -u jun -p. Good. So show databases, then we will have 505 DB. So use 505 DB and then show tables. Oh, actually we have two tables, department and students. This slide does not have department or department students. Department course enroll. So I need to create, let's say here, description department. Then department name is the primary key and chair is something. And description of student. Then CWID name AG major. CWID name AG. AG is not here, but let's say we have AG. So we need to create two more. Okay. So what we need to do is to, Kevin, can you tell me?
Create table
Course.
Open parentheses. Title.
Varchar or text, right? Text and CRM int credit, of course int. What else? Instruct. Text. Semicolon. Course. Fine. And then CWID is int. CRN is int, both are int. We're talking about enroll. So finally we will create table enroll CWID. When I create
You have to make the
primary, I didn't make a primary key. That's fine. We'll go with it. You can you can alter. There's an alter command to add or modify attributes. I'm not sure primary key can be modified once it is deleted. Let's try to do. How can you show tables? We have 3 tables. Course. I want to. When I do, there's 2 different commands: drop and delete. Drop means want to drop entire definition and any records already inserted, populated, will be gone. That is the command called the drop. Delete, if we want to delete any record in a table, then you can use the delete language. So if you want to drop, then drop table, and then course, then it'll be dropped. So if you do short table, then we have 2 tables now. So I want to bring this, and CRN, if this is a primary key, then we can type here at the end of here, and then primary key, or you can do right here, primary key. You can do that. And then description, then CRN is the key. Table enroll CWID int CRN int, and then what should we do?
I think it's foreign key.
Foreign key CWID references. CWI is from student, right? Students CWID, and another foreign key CRN and then course CRN close semicolon show tables, then we'll have 4 tables. Let's play with the 4 tables. Student major references to the department. Course is not here dependent on the department, right? So course will be the independent table. Department is independent table, which means you can create the course and department freely. Enroll is dependent on the course and students. Student is dependent on the department. Dependent means the foreign keys. So we need to create multiple the records for course and department, and then which data can be inserted into first, enroll or student. Suppose we have students, because enroll references the course, enroll references to the students. So students need to first exist. In order to exist the students, department should first exist. But anyway, in that order we can do. I want to try the other way. See what happens. Insert into enroll values CWID, I think 1, 2, 3, 4, and CRN 2, 2, say 5 or 5. If I do this, then probably the complaint here cannot add or update a child row. This guy says enroll is a child row. What is the parent row then? the foreign key constraints. There are four parent row is a student here, and parent row, this guy didn't let us know about the class, the courses, right? This guy is the first, when it comes to this CWID, without even looking at the second value, this guy caught the exceptions, errors, therefore displays. This guy didn't look at this yet. Only looking at the first value and then stop the execution. That is the reason that we have only one error messages. Actually, it should have two error messages, both here and there. Okay. So we need to do, let's see, what else do we have? Select from, student was here, right? Students. Select from student. Oh, we have one student, Kevin. Department. Oh, cyber chain. Okay. So one record each. So we want to add more. Insert into department values, let's say CS, and department chair Smith, semicolon, so that we have two departments, two records in the department table. Insert into student values. We have student ID 1111, so let's see, 1112. Name, age, and major. So we will do name, say Oscar, name, age 21, major, say CS, or if we say method, of course, then it doesn't allow us to do. It says major issue here in the department. There is no department math. So what we need to do is we need to pick one of those, or we need to create the departments, one more records. So it goes into, what if we want to do not one record at a time, but more than one? What should we do? We can do more, right, here? But if we do, we can do more, 1113, say Adam, age 33, and cyber. We can do more like this. And 1114, Davis, age is 29, and cyber. If I hit enter, what would happen? I don't know. It'll give you an error, simply because 1112 I already entered here, right? So I need to change that. Oscar's CWID should not be the same as, Oscar should not be twice, because it violates the uniqueness. Primary key means based on this, so 1119, it's okay. Same Oscar name, same age, same department, but at least this CWID should be different. So if I do this, it'll be okay. So select star from student, then we already have 5 students, right? 3 cyber students, 2 CS students, but student name, all other informations remains the same, only CWID key, primary key is different. Okay, so we have, let's play with the 2 department and 5 students. Okay, so register, so insert into enroll, and then we can say I want to put CRM first, CWID second. How about that? Sometimes you need to do, right? Not in the way, not in the same order as defined. We want to add all different ways, right? In what case do you think it may happen? It may need it. The values are not manually typed, but values may be received from remotely from the internet, from some of the sensor devices. So sensor devices collecting the data continually and sending the data to my database. My database wants to store it automatically. Every time I do not want to change the data coming in, rather I can change the order in this way, then it can go in, right? So that is needed. If data comes from, for example, Wall Street, financial data, then financial data, so long list of data, I do not want to every time reorder of the attributes to comply with my table definition. Rather, I can do it on the insert statements, right? It's clear, it's better. So, I didn't make courses. I need to make courses before we do enroll. Course, values, title, say Python, CRN, 1, 2. That's 3 letters, 131. And credit, 3 credits. Instructor, maybe Peter, right? I can do similarly Python 505, 3 credits, Yoon, and more. Let's say SQL coding 455, 3 credit hours, Yoon, and other course that you are taking right now, Kevin? Forensic computing. So forensic 433, 4:30? 4:30, right? And Usman. Dr. Usman is teaching, right? And what else? What else have you taken so far? Did you take algebra? Algebra that you, what is algebra 116? Where did you take it?
High school?
I think there's a 4 credit hours. High school. Oh, you got the AP? Anyway, what is her name?
I didn't have to take algebra.
Right. You already got the credits. What is teacher's name? Do you remember? You forgot? Higher. Mr. Higher. And then say mobile tech. 3 credit hours. No. 555. Not 44. 555. 3 credit hours. And taught by Dr. Yoon. I want to put more. Network. That is important, of course, right? 350, right? And 3 credit hours taught by who teaches network usually?
Ali, Professor Ali. For network security?
No. Network. I think that is a CISC 350. But anyway, let's say Ali. Hit enter. Oh, all successfully went in. So select the start from course. Then we have that many courses and that many students. So we have student ID 111, 1, 2, 3, 4, and 9. And then CRN likely that we have here at Mercy University. So we want to ask students to enroll. So insert into enroll. As I said, I want to change the order starting from CRN and values. And then I will do CRN 160, 430. Taught by, it is taken by 1111. So Kevin, you are taking that, right? And Kevin is also taking Python. 505, 1111. And then another students 1112. Say 1112 take 131 Python. Something like this. We can do that a little later. What happens? Your SQL check the manual that corresponds to your SQL Server version of the right syntax of near. Oh, I made one more. Close it. Parenthesis. So select the stuff from enroll. So we have that many. Okay. So we have some. Now ready to practice SQL. So list of the course taught by John. So what should we do? in order to list of courses taught by John or Yoon, if we have select the description of the course, then there's an instructor and then course name there, right? So we simply got that from here, this course. So select the course title. I want to list title, and then CRN from instructor. If I stop here, then no, not instructor, the courses. If I stop here, then I can get all the list. But if I want to see only taught by Dr. Yoon, then you need to add the condition. Condition start from where close. So we have select from where. That's what I said here. SFW close. Select S for select, F for from, W for where. SFW close. So we use that. And then here, then I need to describe the condition. So condition, so what is the condition? This condition says taught by Dr. Yoon. Then here, the course table, the teacher can be defined as instructor in the field of the course. So we need to use the instructor here. Instructor should be the same as Yoon. Is database case sensitive or case not sensitive?
I think it's case.
No, it is not. So I'll show it to you. Yoon. Okay. All other programming languages are case sensitive. Scripting languages may not. SQL is kind of a script language, so it is not. I think, but different products supports in different ways. So we'll see if MySQL takes the case insensitive paradigms. See what happens. So this guy is not really sensitive to the letter case. So we have this title and CRN. Those three courses are taught by Dr. Yoon there. What I try to say here, yeah, I think we need to. Okay. So what is it? Students who study the cyber major. So if we do select star from student, then we have that many students. But I want to display only cyber major. Then you can do select star from student. Where, Kevin? Major equal. Programming languages. There's an equal sign and double equal signs, right? In Python, for example, single equal sign means assignment. If you want to check the equality, then you need to put double equal sign, right? Pythons. This equal sign, is it for assignment or equality checking? Equality checkings, right? So this is another difference. Like programming languages, here SQL. Is there double equal sign in SQL? No. So you can see only cyber major. So next one. List students with the course. List the students with the course title that are taken by the students. If you see the students here, student there, we do not know which one they are taking, right? Which, for example, Kevin takes what course? We do not know. But if we see select from student and then select from enroll, then at least I know Kevin, whose CWID is 1111, therefore 1111 is taking 430 and 505. But this guy says we want to see the course title. So course title is not shown up here, right? So where is the course title? Course title can be found, select from course. If we want to see only course CRN equals 430. Only we can see when we get the course. So from this student table, to get the course title, then we need to have something in between, right? What happens here is that these three tables needs to be somehow collaborated, right? So database, relational database is nothing but the collection of tables. Each table consists of columns and rows. Between tables, there is no specific connections. In order to make the relationships in relational database, we need to share the attributes, right? In other words, CRN here is shared by the CRN there, and CWID here is shared by the CWID there. Therefore, these three tables can be somehow connected, related in the real world context, right? In the real world context. So, let's say select CWID, select name, and then select CWID, select name and title, CRN, and then title. From, we want to display only three attributes from three tables. So student table and the enroll table and then course. In the from clause, in the from clause, if we want to join tables, then we need to list them. So 3 tables are joined. We assume students CWID is the same as enroll CWID, where there is a CRN, which should be the same value as the CRN in the course table. In that way, 3 tables are joined together. Okay? So we use select clause and from clause. 2 clauses. If you do 2 clause and hit enter, if you describe select and from only and hit enter, see what happens. Column CRN field is ambiguous. This guy doesn't. You see what I'm saying? Do you want to see? Okay, now we're. CRN appears enroll, appears in the course here. So which one do you want to display? That's what it says. So I want to display, for example, course.crn, and hit enter. What happens? We want to see list of students with the course title. So we want to see who takes what course. Oscar takes algebra. Oscar takes algebra. By the way, you have 2 Oscars, right? 2 different CRN. That's fine. So Oscar takes algebra. There may be some issue. Another Oscar takes algebra. Oscar takes algebra. Oscar takes Python. 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 Oscar takes network. 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 Oscar takes forensics. Why computer science major takes forensics? Oscar takes forensics. Oscar takes forensics. Oscar takes forensics. Oscar takes forensics. Oscar takes secure coding. Oscar takes secure coding. So a lot of nonsense included, right? Lots of nonsense included. In other words, all the records here not reflects the real world context. In reality, Oscar may, let's take it manually. Oscar CWID is 1112, the other Oscar is 1119. Oscar takes 1 Python. Oscar never takes anything about forensics, anything about secure codings, right? Why this happens? This from clause, whatever you list, whatever the tables that you list here, at this phase, it makes all possible matches mechanically, all possible matches. Here we have 2 tables, 2 records, here 3 records, then all matches. So 2 times 3, then 6, right? Let's say how many enrollment, we have 3. How many students? 5 students. 5 times 3, then 15. How many courses? So 7 courses. 7 courses. 3 registrations. 3 registrations and 6 students. Oh no, 5 students. 5 students. Then 5 times 7, 35. 35 times 3, 105, right? So how many we have here? These are all 105. 1, 2, 3, 4, all 105. Okay, these are that many. So how can we clean that out here? So if you want to join without where clause, then it gives us all possible matches. Now in the where clause, then you need to filter that out. Only I want something that makes sense to the real world context. Then what should we do? Then you need to say student CWID is the same as enroll CWID. And CRN. Enroll CRN should be the same as course.crn. In that case, you can see only Kevin takes forensics, Kevin takes Python, Oscar takes Python, right? This is the language. Another tip. See here, you need to say enroll dot course dot student dot. Is there any another way that I can do simplify? Then in the from clause, you need to say student followed by space s, student enroll followed by simplified character e, and course followed by character c. That is the alias that is called acronyms, alias that we want to use it. Then instead of spell out the students, you need to simply say s.cwid equals e.cwid and e.crn equals c.crn. Right? It's handy, a little more handy, having this alias hidden. Then all the way back, I need to say, instead of a course, I need to say c.crn. Okay. Questions so far?
So you can use the acronym before you define it?
Right. In this case. Good question. Right, we defined here, right?
Yeah.
But we use it before we defined it. Why that happens? SQL is not procedural language. It doesn't care about the procedure. If it cares about procedure, then you're right. We first define and then we can use it, right? That is the procedure. SQL is not procedural language. It is a declarative language. Only we declare. So who cares about all those steps and procedures? internally, internal DBMS has a some other modules. It takes SQL statements and convert that SQL statements to the real language, like C language. If MySQL is written in C, then it is converted to C language. Okay. If you see the conversion result in C for any SQL statements, then C language itself is not really neat coding style. It's not clean coding style because that is automatic interpretations. It is really awkward. But question is, does it work? Yes, it should work. But the readability wise, no, it is not really good, the readable coding list. But anyway, that's what it happens. That's a good question. Probably are you good at coding? I think you are good at coding.
Yeah, I need to practice.
Yeah. Then you may do. Okay. The other. So, internal DBMS like MySQL, it has a module, big software packages to the conversion procedures from declarative language to procedural language. And then there is another the components, another software packages called optimizer. So once it is converted well, then it should be optimized so that it can increase the performance. The joining, 3 tables joined together. Sometimes, depending upon we can consider student first. It doesn't have to be considered student first always. It's not necessarily the way it is written here. Right? We can say I can do here, it should give me the same ones. Doesn't have to be, right? So not only the conversion, but also internally optimizations. So it thinks, hey, I want to. So what is it, by the way, in coding wise? If we have 2 tables, how do they make join operation in coding procedural explanations? How do you think they are? It is this. Oops. It's like this. If we have one table here, enroll, another table here, student. In real, when join operation is converted to a real programming languages, then it'll be like this. If I say for each records in E, and then I have 4 other records in students. And then we need to say if each dot CWID is the same as others CWID, semicolon. And then we can say here output you call a list, or you say tuple. Tuple is better. Then you can say if they are the same, then you can say, oh, we need to have a list to manipulate this for a while. Then you need to do output and append that records for them further. What happens here is that I need to have 2 for loops, nested for loops. Okay, 2 lists can be compared together. Then you need to have for loops, right? So take one record from one table and compared each of the records in another tables. And then come back here, the next records, take it and compare. We need to scan all of this again for comparison. Take another and come back here, scanning all for comparisons. That's what we need to do. Again, that is mechanical comparison. Would there be any way that you can improve? Of course you can improve it, right? Depends on the size of the data here and there. A lot of cost evaluations are involved in that optimizer. So converter and optimizer, then it can handle. But in this case, it gives you so quick. Why? We have small tables. Join tables. Why join condition? I already explained that, right? This from close simply gives us all possible matches. So you need to have a where close like this. In the where close, you need to filter out something unrealistic. List who takes what course. We already had that. List who teaches what students. Who teaches what students. Then you need to, same thing, your student, enroll, and course. Then instructor, the course instructor's name and student name. If you do not want to any duplication, then you need to do distinct. Okay. For example, select course instructor name and student's name from student S, enroll E, course C, where students CWID equals enroll CWID and enroll CRN equals course CRN. Hit enter. Only those. Then we need to put more. Let's say I want to insert insert into enroll Kevin takes 555, let's say. Kevin takes 55, and I want to make this. So Yoon teaches Kevin, Yoon teaches Kevin, right? 2 times. I do not want to that. I want to see whether I am teaching that students. Then you need to put here distinct. Then it gives us only Yoon teaches Kevin rather than multiple times. What if we have, for example, how many credits that instructor takes, instructor teaches who? How many credits? Then that is the aggregations, right? How many? Then we need to group by course.instructor. I want to group these tables, group by Yoon, then Yoon or any other. They can be grouped together. That's what group by. As you do group by, let's see, if we hit enter this, then if you use group by, then the reason you have group by, you need to make some aggregation. What is aggregation? Aggregation is I want to put aggregation is this is aggregation. What is aggregation? Aggregation is there is a function. This is aggregation. Aggregation function takes a number of input, 0 or more inputs. Doesn't matter how many, millions, billions inputs, fine. But it wants to return only one. That is aggregation function. N input, one output. That is aggregation function. Aggregate function. What is aggregate function? For example, we have, for example, 1,000 students. Then one of the aggregation function is student name. There are many student names. How many? That means aggregate function. It gives him only one number, right? How many students there? What is the top GPA? among 1,000 students. Then only one number. What is the lowest GPA? What is the average GPA? If somebody answer, oh, it could be 2.7 or 3.1 or sometimes 3.0. Is it a good answer? No, it is not, right? Aggregate function, then given multiple inputs, you should return only one output. Then that is aggregate functions. One clear output should be returned. So, what should we do here? So I want to group the students, group by instructor. So I want to see which instructor teaches how many credits, okay? Then you need to do how many credits, then you need to do sum and course.credit. Then you need to do what this guy says. You have an error. From students. Oh, I deleted where close. No. From what? Oh, here, because of that. Yeah. Oops. What happens? As the name. Oh, student disappeared. The semester. Student S. Another issue. Select C.instructor, students enroll, courses C. Group by colors contains non-aggregated column. Non-aggregated column, which means name is not aggregated. So we need to remove this name. So we have instructor. Instructor is aggregated by, and I think it is. Yeah. Therefore, we need to sum the credits. If we want to see how many courses that this guy teaches, then you can do here count. You can count CRM, right? How many? Rather than count not just CRN, you need to put or enroll.crn. Therefore, Uzman takes one course, Yoon takes 2 courses, Peter takes 1. If you think of the credit hours, then you can do like this. If we want to say as a number of, if you want to rename it, then you need to say here the attribute name is the coding itself. So if we want to say number of courses, I'm not sure the period works, space works, may not. So let's try if this works. Otherwise, then we'll, yeah, it's not going to work. So we need to do, it should be one word, underscore fine. So you need to put here number of courses. Then you will have a number of courses. Aggregate. If you want to aggregate function, then you need to have group by. Without grouping, you do not know, you cannot make one output. One output means per instructor, one output. Per instructor, one output. Without that, you have a per instructor, not one output, right? Left to right join. This is left to right join. You want to see the students without this. I want to go back. Names here and okay, that. So we have the students. Kevin takes forensics. Kevin takes Python. Kevin takes mobile. What is this? Yeah, mobile tech. And Oscar takes Python. Okay. But we do not see this result shows us those students who takes the course currently, the courses, right? Someone may think, not only that, in addition to that, I want to see who do not take the course in this semester. I want to see on the same table the list of the students who takes the course and also list of students who, even if they do not take the course. What should we do? In that case, we need to language here, left to join. So student left to join E on, this is the language, left to join and on. Rather than using from where clause, we have a from and where clause. In this case, select, left to join, and on. This usually appears in the where clause. Instead of this, we together students and enroll, we said the where clause. I mean, that's a from, yeah, from. But inside the from, we need to left to join. So if you want to see here, then I want to see here, students left join. Student S, no, student N, left join. Course on student.cwid equals course.cwid. Let's do these points. Okay. And therefore, we do not have here title. Unknown column CWID. From students S, left to join, course C on, what is this? Unknown columns, CWID. Why CWID is not known? C.CWID, course.CWID, course, oh, not course. Oh, right, it should be inwardly, right, so it should be inward. Course does not have CWID, right? Inward has a CWID. Oops, what happens again? So here it should be not C.CRN but E.CRN. Okay, so now you can see clearly, Kevin takes 430, 505, 555, Oscar takes 131, Adam, Davis, Oscar, the other Oscar doesn't take. So we have null value here. Okay, so
I have a question. So what does left join?
left join means left here. If you see here, left side, student attribute. What is student attribute here? Name. Student attribute needs to be listed, although not matched. Okay. So class instructors are interested in who registered my class, right? But administrator, for example, the president or financial provost in university are more interested in not only enrollment but also those who do not register. Therefore, they need to plan for the next semester to bring them in the classrooms to make money, right? So that is their concern. In that case, not only listing this, want to list those who do not. Okay? Make sense? Good. Left join with the aggregation, that is also possible. So in this case, name and some credit from student left to join and another left to join and group by name. Then we end up having, for example, students, how many courses the students takes. And also we can see those who do not register, right? So let's make it. Select name and some credit from, I think, students S left to join with student enroll, right? So enroll E on student CWID equals enroll CWID. All together needs to be also left to join with the other. So what I can do here, I want to put them in the parentheses all the way here. So we need to left to join the parentheses first, and then that itself left to join with the courses. Course C on s.crn equals to c.crn, and then finally we need to do group by student name. Then we may be able to see which students takes how many credit hours together with those who do not register. S.crn. Oh, the other CRN is not S.crn. E.crn. Enroll.crn. Therefore, Kevin takes 9 credit hours. Oscar takes 3 credit hours. But Adam and Davis, none. Non-registered in this semester. That's what it is. So left to join is useful in some situation, right?
So why did you have to use left join twice in that statement? In parentheses and then
Right. This first two left to join, and then they make that, and then the other left to join. If you do not want, I think you can do also in this way. If you do not want to do it, let's see if it works. I see what you mean. So this together, course C and where close. You want to make like this, right? So one time left to join, and the other is regular join. You see what I'm saying? This returns one table, so that is, so from a table, one and another table. See here.
So that,
I'm not sure this is taken. Let's see what happens. Yeah. Oh, it's not left. This dropped. In this case, in order to save it, oh, I have an idea. In order to save it, you need to do this is a little complicated. Students are left to join. enrollee and course C. This is a little bit complicated. I'm not sure it works, but let's try. So inside here, that is regular join. And with the students, that, and I want to remove the other. If it is, I'm not sure this language can be interpreted properly. Do you see what I'm saying here? Above here, we used double left join. So left join here and left join there, so that we have the result as we want. But if we use only one join, one left join, the result of this, and when I join with the others, a regular join, then the other two dropped. So to save it, I want to make join this first. And the other. Yeah, it's not taken. Then the other idea that I could try this, I want to make right join, student S, left join, then we need to keep the left table. Right join means literally what it means. I want to leave all the columns, all the records in the right tables. That is called the right join. I think this looks a little better than the other. What I'm saying, this looks a little better than this. Still not. So it doesn't take. Only it takes, once you have a left join, then left join, right join, left join, right join. You need to go that way. Let me try this. Is this? No. Okay. Here, oops. That there.
I have a question. So when
Okay.
you use left join or right join, whatever you use it on, that gives you all the
Records.
whole column?
Records. All the records, yeah. Column can be specified here in the select.
Okay, yeah, so
Yeah.
left join gives you all the columns.
All the rows.
Sorry,
Yeah, the rows. Okay. I think this is it for
Yeah.
this semester. I mean, for this class. Okay. Any other questions?
I think okay.
Yeah.
Yeah.
Yeah. Okay. This is it. All right. Hopefully this time I can convert it